Good morning to all of you. I hope I'm audible to you.
Yes, sir. Good morning, sir.
Yes, sir.
Yeah.
Good morning, sir.
So, the part of the laboratory that we are going to conduct, so it is associated with the theory course LiDAR technology. Okay. And as we have already discussed in LiDAR technology, we are going to cover the instrument that we are going to use to collect 3D point cloud data, as well as we will discuss about various methodology through which we identify the various objects of interest. Okay. If you recall the previous discussion, so there you have seen various types of LiDAR point cloud data collected by different LiDAR systems like mobile laser scanning system through road and rail, terrestrial laser scanning system that is operated through a 3D laser scanner mounted on a static tripod, and you have also seen the point cloud data acquired by UAV LiDAR and airborne laser scanning system. Okay, and there we discussed about various objects of interest which are present in the data. Okay, and we have also discussed about the applications where we utilize 3D point cloud data. Okay, so aim of this laboratory is to have a kind of understanding like the how the actual LiDAR system work. Okay, and after that, when you have a point cloud data, then there are various approaches through which we process the data to identify the objects. Okay, so in our laboratory, though you are not here physically, in our laboratory, certain videos are prepared so that through those videos, discussion will be there, like how the 3D LiDAR system, that is terrestrial laser scanning system, operates. Okay, what are the various steps, and how finally when we get a raw point cloud data, how it is processed. Okay, so now I request Mukesh so to start a discussion on operation of this 3D LiDAR system, that is terrestrial laser scanning system. So a video has been already prepared, and through that video, there will be the discussion.
Okay, thank you, sir. So, in this laboratory session, we will start our first experiment. I hope you have the enough background, theoretical background to start this experiment. So, first I will show you the list of experiments to be conducted in this laboratory. So, I am sharing my screen. So this is your syllabus. The first experiment is the data acquisition and registration using terrestrial LiDAR system and registration using the scene software. The scene software will be used for the data registration. And then the second experiment is the 3D visualization of LiDAR data using different softwares like Cloud Compare, QT Reader. Then certain algorithms will be developed uh, to uh, to do the ground filtering of the LiDAR data to separate the ground and non-ground points, and also the DEM generation. And the fourth experiment is to detect the objects like building and tree using some algorithms. So today we'll start the first experiment. So I have prepared one video for the demonstration of terrestrial LiDAR system, and uh, I will show that video and explain the different steps to operate the laser scanner. So this is the ferro laser scanner. The range of this laser scanner is about 330 meters, and for the high accuracy, we generally take the objects within the 100 meters from this laser scanner. And this laser scanner is on
30 meter.
Sir, again repeat, sir.
Uh, I hope you are able to see the ferro laser scanner.
Yes, sir. So did you say that 330 meter?
Yes, yes. It can cover the objects within the 330 meter range. Don't worry, I will explain all these things. And you can see this device is mounted on a tripod. And this device can be used for the different purpose like environment mapping, deformation modeling, DEM generation, etc.
Mukesh, sorry to interrupt you. Could you please go back to the email, this video log, that image where TLS is there? Yes.
Okay.
Okay. See, the range of this system is 330 meter. Meaning is that in our previous discussion, we talked about how range is calculated. Okay. And we also discussed about classification of types of LiDAR system on the basis of its operation, on the basis of mounting platform, and on the basis of types of laser beam we use. So in types of laser beam, we discuss about laser source can generate laser beam, either pulse laser or continuous wave laser. So this instrument, which is available with us in our laboratory, it's a 3D laser scanner. It is it is used for terrestrial laser scanning operations. Okay, and the laser beam is continuous wave laser. Okay, now coming to the range that is given uh, for this LiDAR system, 330 meter means if let's say there is an object away from 330 meter, it means laser beam goes to that object, return back, but due to distance more than 330 meter, the signal that is received at the receiver is very weak. Okay, and that receiver cannot identify. So if object is located more than 330 meter distance, then the return from that object is very weak. So that point coordinate, that range of that point can't be identified. So with every instrument we define a certain specification. Okay, like in this case we can say that it is a medium range laser scanning system. We have a high range laser scanning system that can collect data up to 1.5 kilometer or 1 kilometer. Okay, we have very short range laser scanning system that can collect data only within 100 meter. Okay, so we also do the categorization of terrestrial laser scanning system. It's a subclass on the basis of maximum range that is covered. Okay, so range limitation is only on the basis of what is the internal electronics, how the internal electronic work. If the receiver is not sensitive enough to identify very weak signal, okay, then obviously for the large distance, the point which is very away from the scanner, that point coordinate first the range as well as two angles, the range can't be identified. Okay, so that is meaning of 330 meter. If let's say object is located anywhere in 330 meter radius, there is an optic center. If you see, that will be discussed. So from optic center, 330 meter radii, just plot a sphere. Okay, so the outer surface of a sphere, within that sphere, if any object is there, and if the laser beam is hitting that object and there is a return, then that point range can be identified. Fine. Yeah, Mukesh, please go ahead with your discussion.
Okay. So now I am starting the unpacking of this ferro laser scanner. This is the box in which you can see the ferro laser scanner and the accessories are placed. So we need to mount this laser scanner on a tripod. So you can see this kind of tripod is used for the ferro laser scanner, and this is a lightweight, uh, uh, lightweight uh, carbon tripod. And for the total station, you can see that a wooden tripod is used, and so this is the lightweight and easily can be carried on the survey site. So this is the three-step tripod, and on which the leveling bubble is present. After the leveling bubble is centered, then you can place the laser scanner on it. You can see the bubble here, and it must be, this bubble must be within this red circle, and after that this tripod is suitable to mount, suitable for the mounting TLS laser scanner. So in this way we can mount. So we should be very careful while mounting this laser scanner. After mounting, we can remove its cover. The cover has two locks, and we need to open that locks. After that, this cover can be removed. Generally, we remove the cover after mounting the laser scanner on it. And you can see the rotating mirror of this laser scanner, and it has one SD card slot and one battery slot, and uh, you can also connect the charging unit with this laser scanner if you want to operate it for long hours. So first we need to place the battery in this battery slot. Generally, we are provided with the two batteries, and one battery can operate at least 3 hours. So place the battery correctly within the slot. After that, you need to place the SD card into the SD card module. And this is the battery used for the external power supply, so that the survey will not stop in between. So there are many ways to connect the charging unit to the laser scanner. First way is to connect a 12-volt battery, and then we use a converter from DC to AC converter. Then this adapter of this laser scanner will be used to give the power supply. And another way we can use the we can use the car battery from the car, and we can use the we can use this lighter Yes, this lighter will be used to give the power supply to the laser scanner. So this lighter this adapter is provided. Another adapter is provided with this lighter that can be inserted in the car battery, and we can use for the charging this battery of laser scanner. So these are the ways we can give the power supply to the laser scanner. And this is the SD card module on which we can insert the SD card that will be used for the storing of this collected data. And laser scanner can be switched on by just single click. This button is present above the laser scanner. So just a single click and you can wait, and the display will be open. After clicking clicking this button once, we can wait for some time, and it will and you can get the display. So this kind of display, this is the touch screen display, in which you have to set the different parameters for different scanning parameters to start the scan. In the settings button, you can give the project name, and from the parameter button, you can select the different profiles. Suppose you want to scan the outside outside the building objects, then you can select the outdoor profile. If you want to map the indoor objects, then you need to select the indoor profile. And after that, you can click this start scan green button, and the scan will start. So the scanner will move the horizontally. It can move in in 360 degrees, and in horizontal it vary from minus 30 degree to 90 degree. So a cone of 60 degree below the scanner will not be covered.
Hello, sir.
Yes,
Hello, sir.
yes, please.
Sir, repeat the last line.
So the scanner will cover 360 degree horizontally, and in vertical direction it will cover from it will not cover the uh, 60-degree cone below the scanner. Okay, means minus from
Okay,
the
sir.
vertical direction it will not cover the below minus 30 and minus 30 in the both sides. Means below the scanner the 60-degree cone will not be covered. All other in all other directions it will take the scan. So now we can click the start scan button, and the scanning will start in all the direction except the below the this scanner. So it will cover the facade of this building that is coming in the line of sight of this scanner. And we are trying to map this building. So we are trying to get the 3D model of this building. So this facade will be covered in the scan, and another scan we will try to cover the another side of the building. So in this way we will get the scan, but to combine those two scans we need a registration kit. In the registration kit we have the spheres of fixed width, fixed radius and checkerboards. So these are the unique objects that can be easily identified in the scan. So this sphere, and it can be placed in such a manner that at least 3 spheres must be common in both the scans if you want to merge the two scans. Means the scanner position is such that the three in both the scans, the 3 spheres must be common. So this checkerboard can be placed within the walls and trees with the help of double-sided tape. And this checkerboard must also be placed in a distributed manner. In the same way, we distribute the control points. So one sphere is placed on this car and another is placed near place here. And in the same way, we have placed the spheres and checkerboard. And after that, we will take the first scan. So after placing these spheres and checkerboards, now we are ready to take the scan. So after clicking this start scan button, the scanning will start. So now the scan has been started and I have taken the scan of 15 minutes. If you increase the quality and the resolution of the scan, then time will also increase. Now the scanner is placed at the another location to cover the another side of this building. And after that, collecting these two scans and with the common spheres and checkerboards, we can combine those scans using scene software. So, I will demonstrate how to combine those two scans using scene software in the next laboratory session. And the objective of this laboratory, this today's laboratory, is to know the process of do the surveying using the terrestrial laser scanner. And I have also shared this video in this laboratory file section. You can go to the files, and within the LiDAR lab, I have shared this video, and you individually can see this video. And if you are getting any doubt in this process of surveying, then you can ask. So you can download this video and see individually and discuss with me. And one more thing, you can download the scene software also from this Teams, and this LiDAR Lab folder. You can get the scene software, and you in the next laboratory session, I will demonstrate how to do the registration using the scene software. So you must be ready with this scene installation. And if you get any problem in the installation of the scene software, then you can message in the meeting chat.
सर ये वीडियो कितनी MBs का था? ये अभी तक डाउनलोड हो ही रहा है तब से।
It's only 219 MB only.
सर 219?
Yes, yes.
ओके। हेलो सर।
Yes, Sumit, बोलो.
सर अभी ऐसा कोई लाइडार सिस्टम अभी बना है सर जिसमें सोलर पैनल लगा के हम चार्ज कर सकते हैं, क्योंकि सर इसमें जो बैटरी आपने यूज की है वो 12 वोल्ट की है। तो सर इतना तो पावर सोलर पैनल से मतलब किसी छोटे से पैनल से मिल सकता है ना, कि जो हमारा 12 वोल्ट तक का काम कर सके। तो ताकि हम अगर फील्ड पे हमारे पास चार्जिंग की कोई अवेलेबिलिटी ना हो तो हम वी कैन यूज सोलर एनर्जी।
Yes,
सर इज
yes,
देयर एनी?
yes. We can use solar panel and then charge the battery, and from that battery we can give the power supply. But generally, it is not needed because at the survey side, it is a difficult task to uh, to place the solar panels, and generally we have two batteries, and that battery can work for 6 hours, and then we can use the external battery that can also again work for 2 and 3 hours. Okay,
Nee,
so
sir, I was saying that like in calculators we have small panels which uses the solar energy to work, like we have that 991 MX calculator. So in that way, is there any LiDAR instrument which have such kind of things like small panels which can detect the solar energy and charge itself?
no, actually the so it will make the system somewhat bulky, and so that's why no scanner is available like with the solar panel uh, mounted on it.
Okay, sir.
Mm.
सर हो गया सर देख लिया।
Okay, any confusion is there?
No sir, everything was very clear.
Okay, okay. In the next laboratory session, we will try to merge those scans that are taken during this video. Okay. So
Sir,
you need to be ready with
how can we see that
the software installed in your PC. If you want to visualize that data, that that can be visualized in the cloud compare software.
Okay sir.
So let me demonstrate for you that how you can visualize the data.
Yes sir.
Though it is a part of your second experiment, but I'm just demonstrating that how you can visualize the data. So this is the cloud compare software. It is open source software, and you can just drag and drop the data into the cloud compare. So you can see the different values, intensity, RGB, number of meters, and you can apply all. And this is the airborne LiDAR data. And you can change the color of this. So in this data, you can see the different kinds of objects are present in this data, like buildings, trees, etc. So, and in the same way, you can also visualize the TLS data. So I have the TLS data in my PC. So you just need to, this kind of files will be obtained after the data collection, and you need to drag and drop this file, laser scan file into cloud compare, and all those points will be loaded into the cloud compare. So though it is the part of the second experiment, so I will explain these things later, and how you can crop the data. All these things will be discussed in the second experiment. And the first experiment is still half portion of the first experiment is remaining. That is the registration process. So you must be ready with the same software installed in your PC in the next laboratory session.